Greetings and welcome to Lesson 1.6, Simplifying Algebraic Expressions. In this lecture, we're going to talk about how we're going to start combining variables along with constants, numbers, to simplify our problem into something we could possibly solve. When starting with simplifying algebraic expressions, I like to start with a little story. Now, I believe this is a true story. And what I like about it is it's a story about a queen that kind of outwitted a lot of the smartest, sharpest men of the day. So Queen Dido of Carthage in 9th century BCE, before Christ, before Common Era, she was posed with a problem. And she was given the proposition that her kingdom was going to be taken except for the amount of land that could be surrounded by a fence. Okay, for better terminology, a fence. She was given an ox hide. So if you can imagine a cow hide spread out, it's really not much area. Clever Queen Dido that she was, she figured, how can I get the biggest area out of this strip of ox hide? So how she did it is she cut it into strips, and very tiny small strips, as small as she could get them, and she somehow tied them together so it kind of formed a big circle, like a rubber band type of circle, very loose. She had that stretched out, and it ended up becoming a very large territory. So she didn't lose a lot of land because she was clever. She outwitted the men. Whether it's true or not, I don't know, but it's a nice story. Gives us women some hope that we can outsmart those men out there. So the more modern version of the story is we give you some fencing, and we want to know how large of an area you can fence in. So if I give you enough fencing to go around 24 yards, how large can I make that rectangle? So how we figure out a rectangle is, and I've just drawn quite a few shapes using the same 24 yards of fencing. So the perimeter, what we do is when you have a fence, it goes around the outside of a yard, right? And if I walked around the outside of the yard, I would go a certain distance. That distance I want to go is always 24 feet, no more, no less. How I can do that is form several different shapes. The first one, I can have the dimension of 1 foot wide and maybe 11 foot long, and then again it's going to be 1 foot wide on top and then 11 foot long on the side. So if I walked around, it's 1 plus 11 plus 1 plus 11. So 1 plus 11 is 12, plus 1 is 13, plus 11 is 24. Remember, I always want to add up to 24 all the way around my rectangle. My next shape, I decide, well, that's kind of ridiculous. It's pretty narrow. Can I get more space if I widen it out? And so I decide to build something that is 2 feet wide by 10 feet long, still the same perimeter around the outside. And I think, well, maybe I can do a little bit better. And so I decide to do 3 feet long, 3 feet wide, 9 feet long. And then again, I decide, I can divide it up into 4 and 8, because 4 plus 8 is 12. And then I walk the other half of the shape, and that's 12 as well. So these are all adding up to 24 all the way around. I can make another shape, 5 by 7. 5 plus 7 is 12, plus 5 is 17, plus 7 is still 24. And the last shape I'm going to make is a 6 by 6, ending up to be a square. 6 by 6 would be 6 plus 6 plus 6 plus 6, which is 24. But that doesn't quite answer what space have I encapsulated. How much space have I fenced in? What's the area of the space in there? And we have a formula to figure that out. Area is, I'm going to multiply the length times the width on all of these. So I'll start off, I'll just give you the whole thing. I'll start off with my width of 1 and my length is 11. So 1 times 11 is 11 yards squared. So this shape, this narrow shape, created 11 square yards of space. Now thinking along the same lines, if I take the width and I multiply it by the length, 2 times 10 is 20. So the second space, this area inside here, is 20 feet squared. So the first one is 11 feet squared. The second one is 20 feet squared. The next shape, the 3 by 9, 3 times 9 is 27, so the area I have in here is 27 feet squared. The next one is 4 by 8. 4 times 8 is 32 feet squared. The fifth shape is 5 by 7. 5 times 7 is 35 feet squared. And then our last one is 6 by 6. 6 times 6 is 36. So it appears that the largest shape that I can have is 36 feet squared, the largest area. And here's why I know that. Because when I get down to 6, my dimensions just swap. Now my width is 7 and my length is 5, and 7 times 5 is still 36 or 35. So I start to have this decrease after this peak, and it will actually go down. So I know the topmost is a 6 by 6 square. That's the largest area that I can get. Now we talked about a perimeter and we talked about an area. We have formulas for those. So here's our perimeter formula. Our perimeter will equal 2 times the length plus 2 times the width. And if I scroll up to our shape, you can see why that is. My perimeter, I just walk around the outside of my shape. So it's going to be my width plus my length plus my width plus my length. So I went 2 lengths, I went 2 widths. So my perimeter is going to be 2 lengths plus 2 W's, widths. Now, and I explain how I get 24 for my perimeter and work with that, but I want to skip down to area. My formula for area is length times width. And because it's length times width, I just quickly say length, which was 6, width, which was 6. 6 times 6 is 36. I'm going to throw some vocabulary at you, and we do need to kind of talk the same language. I think one of the most difficult things about math is if we don't speak the same language, you might as well be speaking English and I might as well speaking Spanish, and we don't understand each other. So we do need to share the same vocabulary. And one of our vocabulary is a term. A term is a single number or a variable or a combination of them which are multiplied together. That is a term. Terms are separated by addition or subtraction. For example, one term would be the number 4, an x times y, an x squared times y, a 7x, a negative 3xy z squared. The only separation between any of these, the x times y or the x squared y, these are multiplication. There's no addition and subtraction, so that is one term. Now examples of two term would be x minus 3. The first term is x. My second term is 3. Two terms again. I have 4x minus 3y. My first term is 4x. My second term is 3y. For 7a squared minus 8b squared, my first term is 7a squared. My second term is 8b squared. For my fourth example, my first term is x squared y. My second term is 5. And that's for the whole problem expression of x squared y plus 5. Now for my last example of two terms, I have x squared y plus xy squared. Now you might be asking, wait a minute, they both have an x, they both have a y, why isn't that one term? Well, not only does the variable have to match, the power of the variable must match. So x squared y is not the same thing as xy squared. And because of that, I can't combine the two and make it one term. They are separate terms. Two terms in an expression has a very special name. It's called a binomial. Now we also have 3 terms, 4 terms, 5 terms, 6 terms. So let me just move me out of the way here. For 3 terms, x plus y plus 3 is an example. And you can see x would be your first term, y is your second term, 3 is your third term. You see where I'm going with this. Negative 3x 8 plus 8y plus z. First term, negative 3x. Second term, 8y. Third term is z. A minus b plus c, that has 3 terms. X squared plus x minus 2, again 3 terms. X squared y plus xy squared plus z cubed, 3 terms. Again, we have a very special name for a 3-term expression. This is a trinomial. Now, once we have an expression and we have several terms, we want to be able to simplify our expressions. We have a couple of properties we want to recall. We have our associative property. That means I can regroup things, do some math, and simplify it. For example, I have 2x times the quantity, 5x. Well, if I regroup, instead of the parentheses being around the 5x, I regroup it to where the parentheses are around the negative 2 and 5. Now I have negative 2 times 5 times x. I can combine that negative 2 and 5 to be a negative 10x. That's as simplified as I can get it. The associative property just means that I regroup it. You want to try and regroup it with numbers together and variables together. Another example would be 3 times the quantity negative 4y. Well, 3 times the quantity negative 4y, I can rewrite it as 3 times negative 4 times y. Well, 3 times negative 4 I can do. That's negative 12. So negative 12y would be my most simplified expression. For another associative, perhaps I need to combine some addition instead of just multiplication. So I have 2x plus 5 in parentheses plus 10. But I can regroup it to where it says 2x plus 5 plus 10. I can do the 5 plus 10, so now it's 2x plus 15. Now you might be asking, why don't I just combine the 2x plus 15? Well, here's the problem. You would want to combine apples with bananas. And that we're not going to do. We're only going to combine apples with apples, bananas with bananas, oranges with oranges. So they're called like terms. Again, we have some terminology here. So similar terms or like terms are terms which the variables and their exponents are the same. A coefficient is the number in front of a variable. And we do want to recall one of our properties. We have the distributive property. A times the quantity B plus C is going to be AB plus AC. So keep that in mind. So here's an example that we want to simplify. 2 times the quantity A plus 3. I'm going to distribute the 2 to the A and the 2 to the negative 3. So 2 times A minus 2 times 3. Well, 2 times A is just 2A minus 2 times 3. 2 times 3 is 6, so it's 2A minus 6. Now the 2A has the variable of an A. The 6 does not have any variable, so I cannot combine them. So that would be my most simplified answer. Let's try another problem. 4 times the quantity 5x plus 3. I'm going to distribute the 4 to both the 5x and the 3. So I have 4 times 5x plus 4 times 3. Using my associative rule, I can regroup the 4 times the 5 first and do 4 times 5x plus 4 times 3. 4 times 5 is 20, so 20x plus 12. And I've given you some examples to work through. The example of 4x plus 3x. Using my distributive property the reversed way, I'm going to take out an x out of both of them. And because I can take an x out of both of them, now I have the grouping of 4 plus 3 times x. Well, 4 plus 3 is 7, so my solution is 7. The other way you can think about this is I have, and I hate to make this such a, dumbed down or simple example. I don't mean it that way. I just think of it easier if we're all thinking kind of in simple mode, I guess. So I have 4 apples and I have 3 more apples. How many apples do I have? Well, I have 4 apples plus 3 apples. 4 apples plus 3 apples is 7 apples. In our example, we just have x's. I have 4 x's plus 3 x's. Well, how many total x's do I have? I have 7 x's. It is not multiplication. It is not making into a power. It is just adding like things. In this case, I have like x's. And I would like you to go through the original expression for all of these. Pause the video. Look at how we can pull out the common variable and then simplify the expression. We have a rule, the distributive rule, that allows us to do this, but if you think in terms of those, hey, I just have apples, I just need to combine all my apples, how many apples do I have? I think in my mind it's a little bit simpler to understand. The last thing I want to run through are algebraic expressions for area and perimeter. And the 2 shapes that I give you right now are a square and a rectangle. The square, the sides are equal. So you're usually only given one dimension. You're given one length of a side. If you're given one length of a side, then you know the other sides are the same length. The area will be side times side, or you can think of it as side squared. And then the perimeter, well, I'm walking all the way around my square, so it's side plus side plus side plus side, which will be 4 times side. We're going to get out of this addition train of thought and start working with algebraic expressions. So I do want you to work with 4s and not s plus s plus s plus s. Likewise, with area, I want you to make sure that you're using s squared. I'll accept s times s, but you really should think of it as s squared. With a rectangle, my area is going to be my length times my width. And then my perimeter, it's going to be length plus width plus length plus width. I have two lengths, I have two widths, so my standard formula is 2L plus 2W. But there's one more thing we can add to that. We can pull out the 2, and it could be length plus W. So either one of these expressions will work for a perimeter. If you like to remember it as 2L plus 2W, that's fine. If you want to remember it as 2 times length plus W, then remember it that way. Let's work with some examples. Let's find the area and a perimeter of a square with a side of 6 inches. Now, the good part about this is square, the area is just the side times the side. And we know what our side is, 6 inches. So it's going to be area equals 6 inches squared. Well, 6 inches squared is going to be 6 times 6. Let me rewrite that. It's going to be 6 inches times 6 inches. Well, 6 times 6 is 36. We know that part. And inches times inches is inches squared. Now, there's a couple ways that you can write it. You can write it square inches or inches squared. I don't mind which version. But you do need to have your units. Okay, we need to know we're talking about inches. If we're given inches, our answers should be in inches. And then our perimeter is going to be, perimeter for a square is going to be 4 times s. Our s is 6, so 4 times 6 inches will result in 24 inches. Let's try a soccer field is 100 yards long and 75 yards wide. Let's find the area and the perimeter. Our area for a rectangle is L times W. So area equals length times W. And our length is 100 yards. Our width is 75 yards. Apologize for my writing. I'm kind of writing on a wall, so it's a little weird. And now, 100 times 75 is going to be 7,500. Yards times yards is yard squared, or yards squared. Now let's find our perimeter. Our perimeter, I'm going to use our 2 times length plus W formula. You can use either one. 2 times 100 yards plus 75 yards. Well, that's 2 times 175 yards. 2 times 175 is going to be 350? 350 yards. Okay. Now that's it, what I want to cover for this video. There is one extra step that you may want to do. Rewrite the expression for an area in terms of width. So if our area is length times width, then I can rewrite it in terms of width is our area divided by our length. Why can I do that? Because right now, length is multiplying width. If I undo that, what's the opposite of multiplication? Division, so I have to divide the other side by length. That's it for this lecture. So until next time, be seeing you.